Hello, my name is John Davidson, and welcome to Math 230, Differential Equations at Southern State. The textbook I'll be referring to in these videos is called Ordinary Differential Equations. It's by Morris Tenenbaum and Harry Pollard. It's a rather old book, dates to 1963, and it's cheap as textbooks go. It's a Dover book, and you can find this in some bookstores. Like Borders, for example, I know has it, stocks it, I'm sure there are others. It's a very thorough book. It's a great reference book. I'm sure that's why it's still in print. And but it's also very thorough and very formal. Very formal in the sense that there are definitions and proofs, and he lays all the groundwork for this in a formal way, which does not make the textbook very easy to read sometimes, but that's what I'm here for, to help you sort through this stuff. So now the videos support this course, and I should tell you that I'm in my spare bedroom talking to myself in front of a camera, and the board is only 4 feet across by 3 feet high. And some of these problems get rather long, and so the nice thing about this is that you can pause and rewind, but you really ought to be taking notes. You should always take notes in a math class, but particularly here because I'm going to have to do a lot of erasing, and because some problems will take several boards to complete, and so it'll be kind of awkward because I don't have a single big wide board where I can lay everything out on. All right. The other thing to consider is that these videos, I'm putting them on YouTube, and YouTube only allows 10-minute increments, so often I'll have to just break a video in some place, and so I can split it up into 10-minute increments. And so we'll have a bunch of short videos on the internet for you on this. Okay, well, why ordinary in the title of the book? And probably it would make a lot of sense to call this class Ordinary Differential Equations. An ordinary differential equation is an equation with an ordinary derivative in it, a dy over dx, for example. And what else could there be? Well, if you've taken a multivariate calculus, if you've taken, say, a calculus 4 under a quarter system or a calculus 3 under a semester system, then you're aware that there are other kinds of derivatives called partial derivatives. And a partial derivative, for example, looks like this. This is the partial of f with respect to x. That's the sort of notation you see with partial derivatives. It's also f subscript x is a partial derivative notation. Well, partial derivatives equations are much harder to solve, and in fact there are really not too many of them that can be solved by functions we're familiar with. Most of those have to be solved by numerical methods. So, but anyway, that's a topic for normally what's considered a higher level course. Introduction is always with ordinary differential equations. Now I should tell you, this topic has been so well researched, it's almost a dead area for research, from my knowledge, that we can solve about every ordinary differential equation reasonably come up with. And so not a lot of research going on, but it's a cornerstone to applying mathematics and applying calculus in different settings. If you're an engineering major, then if you do enough high-level engineering, then you need differential equations, because you'll need to solve those for various kinds of problems. And if you're a physicist, you'll encounter differential equations. A math major, it just goes with the territory, being a math major, learning how to solve differential equations. So with that in mind, I'd like to do a lot of applications in this course. I want to show you how differential equations are applied to physical situations. So I'll be doing physics problems, some physics problems in here. And if your physics background is light, try to relax, because I'm going to explain everything. I'm not going to assume that everybody watching this video has studied at least a year of calculus. I'm sorry, at least a year of physics. And so I'll walk you through what you need with that. But it's important, I think, to learn how to apply differential equations if you're going to learn the topic.